Why do the leaves change color in the fall? In order to understand why there's color change, we gotta take a couple steps back and talk about chlorophyll. What is chlorophyll? Most of us have heard about chlorophyll. Chlorophyll is a molecule that allows plants to convert sunlight into energy. Specifically, chlorophyll is what's called a pigment. A pigment is a molecule that absorbs and reflects light. White light is made up of a spectrum. This spectrum consists of the colors red, orange, yellow, green, blue, and violet. When I was growing up, the acronym, I'm not sure if it's still talked about now, but it was ROY-G-BIV. That's the bread and butter to really understand the colors of the spectrum, or at least to remember the colors of the spectrum. Everything that we see that has color because it absorbs and reflects light in the spectrum. Let me give an example. Think of a red apple. Red apples have a pigment on the skin that absorbs every color in the spectrum except red. It doesn't absorb red very well, so red bounces off the molecule and we see it as red because that's the only color that the pigment could not absorb. It's the same with a green apple. Green apples have pigments on the skin that absorb pretty much every color except green, so green is reflected back at our eyes, which is why we see green. Now that we've learned a little bit about how color works, let's talk about chlorophyll again. Chlorophyll, like I said, is a pigment. And this pigment reflects green because it doesn't absorb green very well, which is why we get all the beautiful greens when we see green plants. All right, now we're going to talk about the seasons and how chlorophyll plays a big role in the color change, especially as the temperatures get colder. In the summertime, especially in the warmer months, chlorophyll is constantly replaced in the plant. This is why the leaves are so green and vibrant in the spring and the summer, specifically the summer when it's nice and warm. But as temperatures drop and get cooler, especially in the fall time, chlorophyll production stops. Think of an assembly line. When we see assembly lines, they're putting products together and pumping things out. In this case, the assembly line that produces chlorophyll stops. Chlorophyll then gets broken down and the plant uses some of those pieces for nutrients. As the temperatures get colder, the trees pull nutrients from the leaves and shut down chlorophyll production to prepare for the cold weather. When chlorophyll stops being produced and the nutrients get pulled away, we see that there's other pigments in the leaves that give off beautiful colors as temperatures get colder. So how do we get these colors? Well, what's left over when chlorophyll leaves a party are these molecules called carotenoids. These are pigments that are orange, yellow, red, and really anything in that spectrum of color. First one I'm going to talk about are xanthophylls. Xanthophylls reflect yellow very well, and they're present in corn, which is why corn is so yellow. Then we have carotenes. Carotenes reflect orange very well, and they're present in carrots, which is why carrots are very orange. Then you have anthocyanins. Now, anthocyanins are interesting because if you ever look at purple vegetables or berries, anything in that red to purple range, those are anthocyanins. And they really show up as the temperatures get very, very cold. They seem to be activated by the cold weather. So I've talked about yellow, orange, red, green from the chlorophyll. But how do we get all the variety of colors? Like the browns or the golden browns? Well, these come from different combinations of carotenoids and chlorophyll. So for example, if it's fall and the leaves are brown, that's a combination of anthocyanin and chlorophyll. If the leaves are orange or orange-red, that's a combination of anthocyanin and carotene. If the leaves are really, really bright, vibrant red, that usually means the temperature is very cold, and those are anthocyanins showing up to the party. So in summer, we talked about light and color, gave an example of that red apple. The red apple is red because those pigments on the skin don't absorb red very well. So when the white light hits that pigment, red gets reflected back, which is why we see the color red. And chlorophyll's green because chlorophyll reflects green very well because it doesn't absorb the color green. As the seasons go on, especially gets colder, chlorophyll goes from being produced heavily to not being produced at all. Those nutrients get pulled from the leaves and more pigments come out. Talked about xanthophylls present in corn, carotenes are present in carrots, anthocyanins that are in the red, purple fruits and vegetables. And these are the carotenoids. And then the varieties of colors, the yellows, the browns, and things like that come from a combination of carotenoids and chlorophyll. That's where we get all the varieties from. So thank you so much for watching and listening. Please like, comment, and subscribe. Tell your friends, and I'll be back soon with another video.